for problem number 2. Problem number 2, basically, we would like to show the property of associativity in complex number. So this is also very straightforward. We just need to write down alpha, beta, gamma in terms of, or in the form of a plus bi, something like that, for each of alpha, beta, and gamma. And then the associativity of real numbers will be used to prove the associativity for complex numbers. And also it's the same for problem number 3, the associativity of multiplication and the distributive property of multiplication and addition in complex number. All of them is inherited from the property of, for the same property in real numbers. So because in real numbers we have all of these properties: associativity for addition, associativity for multiplication, and distributive property for multiplication and addition, then it will carry over this property to complex numbers. So I think I don't need to do all this problem, but just for an example of how can we do this, let's do problem number 4. Okay, so let alpha, beta, and gamma be complex numbers. Write alpha as a plus bi, beta as c plus di, and gamma as s plus ti. Okay, so we would like to show that, well, I don't use the same letter, but it's not that a big deal. So we would like to show that gamma plus times alpha plus beta. So just write down gamma as s plus ti, and then alpha plus beta as a plus bi plus c plus di. According to the definition of addition, the expression inside the parenthesis is equal to a plus c plus b plus di. And then if we multiply with s plus ti, we get, so s multiply with a plus c, s a plus c, and then we multiply s with that guy, s b plus di, and then we distribute this ti to a plus c, t a plus c I, and then we multiply ti and b plus d times I. And remember that I times I is equal to I squared, which is -1. So this is equal to minus t b plus d, something like that. Okay, so now we collect all expression without I and all expression with I separately. So this is equal to s a plus c minus t b plus d, and then we combine all this expression that has I on it, so we get something like that. Okay, so one way to show this is to do some manipulation step by step until we get this expression, right? So in order to do so, we need to direct our manipulation so that in the end we get this kind of expression. Or another way is just compute so on the other hand, if we do gamma alpha plus gamma beta, this is equal to S plus Ti times alpha A plus Bi plus S plus Ti times C plus Di. So this is equal to AS minus BT plus SB plus ATI plus SC minus TD plus SD plus CTI. Okay, and then we can rewrite this, add this with that guy AS minus BT plus SC minus TD, okay, plus SB plus AT plus SD plus CTI, and then we want to make this looks like this expression. So can we do that? Yes. So for example, this and that, we can factor out the S as A plus C, and then minus T B plus T, and then here we have factored out the S, B plus T plus T, A plus C, I. Okay, and then we can say that since this guy and that guy are exactly the same, therefore we have the distributive property of complex number. Since star is equal to double star, therefore alpha gamma alpha plus beta is equal to gamma alpha plus gamma beta. Okay, so that's all for problem number 4, and you can do the same for problem number 2 and number 3. So it's basically just writing down the result of addition or multiplication, but do not skip the exercise. Please give it a try. It will help you to build your confidence in doing problems. So that's all for now. See you later on the next video. Bye bye.